everybody, welcome to another episode of Teardown. Today we're going to be tearing down the gwolves HT-2S Pro. Now this mouse, while being one of gwolves' more unique recent releases as it has this hybrid shaping that's reminiscent of the gwolves HT-S Ultra with this symmetrical forward region, but then also like the HT-R Pro with this ledge-like rear region here. But despite this hybrid shape, this mouse does maintain the same great serviceability as many of other gwolves mice. However, the disassembly process for this mouse, like it was in the HT-R Pro, is a little unique compared to gwolves' other mice, so it's a little more complicated, but the unit is still very user-serviceable, which is great to see. So if you need to clean the mouse's shell due to its very open design to prevent debris-related issues, replace a component or mod the mouse's battery, it's relatively easy to do so. And in today's episode of Teardown, I'm going to guide you guys on how to fully disassemble and reassemble this mouse, talk about the mouse's PCB layouts, its component weights, and much more. But as always, you will need a couple tools to take the mouse apart. Firstly, having a precision set of screwdrivers will be very helpful, and also having some plastic pry tools will be very beneficial. Now, all of the screws inside the mouse are Phillips head screws, but they do vary in size slightly. However, some of them are inaccessible with traditional screwdriver types, and you will need some longer neck screwdrivers like this one in order to disassemble the mouse, just as we needed for the HT-R Pro. So make sure you have a screwdriver with a longer neck like this one that has Phillips heads bits, as you will need it to take the mouse apart. And lastly, having something like a soldering mat to keep your mouse in place as you tear it apart will be very beneficial. Now, I like to use a soldering mat like this one because it has built-in screw storage and component storage, so it makes the disassembly process much easier. You can use pretty much whatever you want to do this teardown though, so if you don't have this, don't worry about that. You can use whatever you want. Just make sure you have something to keep the mouse in place as you take it apart, and make sure you have something to help you keep track of all the screws that go inside the mouse. But once you've assembled all your tools, you are ready to go ahead and take apart the gwolves HT-S2 Pro, so let's go ahead and get started. Alright, now firstly, you're going to go ahead and take your mouse and flip it over. Now normally on most mice, you have to take off all the mouse's skates in order to access the base screws. However, all the base screws are actually on the PCB here, so you don't need to remove the skates. I have in my case, but you can take this mouse apart while leaving the skates intact, which is a great thing to see, as wasting PTFE skates sucks whenever you have to service a product. Now before we take off the screws here on the main board, we are actually going to go ahead and remove the main clicks. As I alluded to earlier, this mouse's disassembly process is very similar to the HT-R Pro, which we had to remove the main clicks before we moved anything else, and the same process goes here, hence why you need these thinner neck screwdrivers. Now what you're going to have to do is you're going to have to stick the screwdriver in through the bottom of the shell to access these two anchoring screws on each click right here. However, you need to be very careful in doing so because the mouse's battery is right here, so be mindful of this because this battery will catch fire if it is punctured, so make sure to keep the bit off to the side always and never puncture the battery like this. Now with that warning aside, let's go ahead and take out these screws. Now I'm going to do my best to show you guys how to remove these screws, but basically you want to put this screwdriver through this hole here and here, just angle it as needed, and the screws for the clicks are right there and there. Now I'll do my best to show it as I take it apart, but it might be a little difficult due to the size here. Alright, and then with those screws removed, the main clicks are now loose, and now you can take a plastic tool, or I like to take a flathead screwdriver, and put it into the bottom of the shell, and you want to pick up the clicks as best you can to dislodge them from their anchoring points. So we'll do that here, and that also on this one here. Again, just be mindful of the PCB. And once that's done, the clicks will most likely fall out of the shell. Sometimes you might need to stick a finger in there just to kind of pull it loose, just like that, and the clicks will come off in one solid piece. Again, the exact same disassembly process for the main clicks, at least, like we saw on the HT-R Pro. Now I'll put these off to the side for now, and now this is exposed, but you can see two anchoring screws towards the front here, and there are all these other screws on the base of the motherboard here as well, so we can now go ahead and remove those. Alright, and then with those screws removed, we can now go ahead and remove the main PCB here. However, as we've seen on many gwolves mice previously, we can see that the structural support for the side shell here is actually the PCB itself, as it anchors into the side shell in several areas. As such, what you need to do is you need to kind of peel the side of the shell out a little bit to disconnect the PCB, just like that. You can gently pull it up, and then towards the front there are these two prongs here, which you'll need to pull in as well. And then the tricky part is you have to basically finesse this entire thing out of the shell which can be a little tricky. Now, the biggest issue here is going to be the scroll wheel. As you can see here, it's kind of stuck like that. So you need to do this in a way where you can get everything out properly. And you can do this by angling the PCB outward and then just gently shimmying it back just like that to disconnect the PCB. Just be really careful because the PCB is very fragile, so it's very easy to snap. So just be very gentle when you do this. Now, as expected, there is a small ribbon cable running to the side button PCB here, so we have to be mindful of that. And we can disconnect it by grabbing the side of that black connector there, pull it up into the open position like that, and then very gently pull this ribbon cable out just like that. And with the PCB removed, that is how you disconnect the top and base quote-unquote shells here. We're going to put the base off to the side for now, and let's go ahead and talk about the top shell next. Alright, now for the top shell here, there really isn't too much to do here, seeing as we already removed the main clicks. However, we can remove these side buttons themselves and of course the side button PCB, which is quite easy to do as there is just an anchoring screw here and here, so we can go ahead and remove those. And with those screws removed, you can just reach in with a finger and just gently pull up on the side of this PCB to disconnect it. You might have to do the same on this side. Just wiggle it off just like that, and the PCB will come off in one solid piece. But just like the main board, be very cautious because it is rather thin, so be careful not to damage it. And we can also see that gwolves has implemented a double-sided connector for the ribbon cable. So if this cable does get damaged somehow, you can just replace the cable, not the entire side button PCB itself, which is a great thing to see. We'll put that off to the side for now. And now lastly here on the top shell, we can go ahead and remove the side buttons, which we can do the traditional way. As you can see, they're anchored into the corners there and there. So we're going to reach over with our fingers, push the buttons into the shell, and then you can take a fingernail or a screwdriver in my case and push up on the side here just to kind of push them out of place. And then once they're kind of pushed out, you can go ahead and grab them as a whole and pull them out of the shell just like that. Alright, and with the side buttons removed, that is everything for the top shell here. A fairly easy disassembly process, albeit the uniqueness of taking the clicks out first, but a relatively simple process nonetheless. We'll put that off to the side for now, and now let's go ahead and talk about the base shell or the main board here. Alrighty, now the base shell here for the HT-S2 Pro is just the main board, as we've seen on many gwolves mice. They don't often have a bottom shell, so this is going to be pretty easy to work with, as there really isn't a lot to do here. Firstly, we can go ahead and disconnect the battery by removing this JST connector here, which we can gently wiggle off. And just again, be very mindful as the PCB is very fragile, so make sure not to put too much pressure on this connector. I'd recommend holding close to it like this, and with a little bit of pressure, you can pull off the 2mm 3-pin JST connector just like that. And with that removed, the only other thing we can do here on the main board is remove the scroll wheel, as we can just pull it to the side and pull it out of the shell just like that to remove it in one solid piece. Now the battery here is removable. As you can see, it's held on by this little adhesive pad here. Now I'm going to remove it for my teardown here, but you don't need to do so. However, if you want to mod the mouse's battery, as I talked about in my full review, the mouse does include 2 extra adhesive pads for the battery. So if you want to mod the mouse's battery for a lighter one or a different capacity, you can use these pads to replace it, as these are a nice lightweight alternative to traditional double-sided tape. Now I'm going to go ahead and take my battery off by just gently peeling it off the base here. Again, just be very mindful because the board is rather fragile. Now this foam will likely just peel apart as it's doing here, but you can just pinch off whatever excess parts there are there, and there's going to be a little bit there, but I'm just going to leave that there. And then we can also clean off the bottom of the battery, but I'm going to do that off camera. Alright, and with the battery cleaned off, that is everything for the base shell's disassembly. Next, let's go ahead and grab our PCBs and our other components and talk about the board's PCB layouts and specs. Starting off with components, we'll start with the battery here, which is a 250 mAh battery, the same size gwolves use in a lot of their full-size mice. They often go with 200 or 150 mAh batteries for their smaller fingertip optimized ones, but this is the standard battery size we've seen in a lot of their other mice. But again, this is very moddable, so if you want to mod this out for a smaller capacity or a larger one or a lighter battery, you can do so very easily. Next up, we have the side button PCB here, which is using 2 TTC brown shell blue dot micro switches, the same micro switches we saw used on the HT-S Ultra and several other mice this year, which are well implemented. However, they are on the heavier side, not because of the switches, but because the stemming on the side buttons is a little thicker than we've seen gwolves use before, which makes the side buttons feel a little heavier despite the great side button implementation here. And then for the main board here, we have a typical style gwolves very weight optimized main board, which is again very fragile, so just be very careful with it, which is sporting a Pixar 3950 DMT5QU sensor, a Nordic 52840 MCU here, a TTC 9mm encoding encoder if my memory serves me correctly. The same encoder type we've seen gwolves use in many of their other mice, just a shorter style. We have an unknown pillar switch here, which I'm pretty sure is a TTC pillar switch design. Again, I don't really like these pillar switches because they're a little spongy feeling, but they function fine for scroll wheel clicks. And the big differentiating factor here is that this mouse is using 1.0 green shell white dot switches for the main clicks, not the blue shell variants we've seen gwolves use before. Now these switches, while they are a different SKU from the blue shell variants, actually feel pretty much one for one, and the only real noticeable difference between these and the blue shell variants is that these are ever so slightly heavier in some cases depending on binning, and these are rated for 10 million cycles while the blue shell variants are rated for 80 million cycles. But while it is a rather rare switch as we don't see too many mice use these are very well implemented here on the HT-S2 Pro, and I'm quite happy to see them here. Alright, well that's everything for the mouse's specs and components. Let's go ahead and talk about the mouse's individual component weights next. Alright, now as a preface to this segment, gwolves is advertising that the HT-S2 Pro will weigh around 28.4 grams. However, that weight is not accounting for the added weight of the grips and the stock skates. However, this mouse actually stays pretty close to the industry standard plus minus 2 grams on said weight spec, which is a great thing to see. gwolves' previous mice have often been well outside their advertised weight spec, but this one is much more accurate. It is still technically speaking outside of the weight spec, but it's much closer than we've seen before, and hopefully we'll see gwolves continue to refine their advertised weight specs in the future. But despite the mouse's advertised weight, let's go ahead and weigh the components. Starting off with the top shell, which has everything removed from it, which weighs 7.76 grams. Next, the two main clicks collectively weigh 5.54 grams. The mouse's side buttons weigh 0.79 grams. The mouse's scroll wheel with its rubber texturing still installed weighs 1.9 grams. The side button PCB with its ribbon cable still attached weighs 1.27 grams. The mouse's main PCB, which has been very weight optimized, weighs only 7.66 grams, which is very impressive. And lastly, the mouse's battery and its adhesive pad weighs around 4.47 grams. Alright, now that we've gone ahead and talked about the mouse's component specs and we've gone over the individual component weight, let's go ahead and start our reassembly process, starting with the main board here. Alright, now this process is going to be pretty straightforward as we really don't have a lot to do here as the mouse is pretty easy to disassemble. Firstly though, we are going to go ahead and reconnect our battery. Now again, you don't have to remove this like I did in this video. I just did this to show you guys how to re-anchor the battery in this case in case you want to mod it. But as mentioned earlier, you can take the included extra adhesive pads or whatever adhesive you would like. You can go ahead and peel off this top layer here and you can stick the base to the battery just like this. And then once you're satisfied with the placement, you can go ahead and peel off this side of the adhesive as well. And then you can go ahead and position the battery. But it is worth noting you need to be very careful in doing so as the battery is the crux of the mouse's balancing, and it is going to be a little difficult to tell if the mouse is balanced due to how it's assembled. So you'll need to kind of guesstimate how the mouse is going to be balanced. Now if you're reinstalling the exact same size, capacity, and weight battery, you can just put it back exactly as it was. However, if you change the size or the dimensions of the battery, it will skew the mouse's balancing a little bit. So keep that in mind when you reinstall your battery and adjust it as needed. But for our case, since we're just reinstalling the stock battery, we can just centrally position it in the base shell here, kind of like that. You just want to make sure it's even. And then with the battery installed, we can go ahead and reconnect this JST connector by just gently lining it up into place, taking our nails on the side and pressing down just like that. And then once that's connected, if you do end up replacing the battery, just go ahead, flick the mouse on and make sure this LED turns on to make sure the battery is functional. Now with the battery checked, we can go ahead and flip the board over, and now we can go ahead and reinstall the scroll wheel. And we can do so by taking the shorter end of this wheel and putting it into that little hole in the encoder. So just drop it into place, line it in, and just poke it in just like that. And unlike gwolves' previous mice, we don't have any standoffs coming from the bottom, so you don't need to worry about giving us a little bit of play on the sides here like this. You can push it fully into the encoder, as the only supports for the scroll wheel here are these little indentations in the top shell, nothing from the bottom, so it makes it a little easier to install. But with the battery and scroll wheel reinstalled, that is everything for the base shell reassembly, quote unquote here. We can go ahead and put this off to the side, and now we can go ahead and reassemble the top shell. Alright, now for the top shell, this is going to be a pretty easy process again. Firstly, we can go ahead and take our main clicks, and we're going to go ahead and drop them into the side of the shell here. Now you can see how there are these little nubs here, and they correspond to these little holes here and here, and there is also a central one here that corresponds to this little plug here. So what you want to do is kind of line them up into place as best you can on the side of the shell, and then just press them in and down making sure they kind of rest into their proper little nooks there, and with enough pressure they will clip into place just like that. And once they're installed, just go ahead and press the buttons to make sure they still actuate in the shell. Now if you feel a little bit of grinding on this, it's most likely because it's not installed properly, so just give it a little bit of pressure on the bottom and make sure it's sitting flush into its little nubs there. With that installed, we can go ahead and grab our side button PCB, and we can go ahead and reorient that into the side shell, and these little holes here and here correspond to the standoffs here and here. So we can take the PCB and drop it into place just like that, and you can make sure it's sitting even. As you can see, the plastic for the pilot holes is roughly even with the PCB surface, and then you can go ahead and re-anchor the anchoring screws that go here and here. Alright, and then once the side button PCB is reinstalled, go ahead and check your side buttons to make sure they still function. Make sure they feel even in their actuations and make sure there's no grinding on the buttons, but they shouldn't have any issues as you push them in earlier. Now with that, that's everything for the top shell we can do for now, as in order to reinstall the main clicks, we need to reinstall the PCB. So let's go ahead and do that next. Alright, now the process for re-anchoring the PCB into the top shell is a little odd, as again, we kind of have to angle this in a way where these two little holes here go over their standoff towards the top of the shell, but we also need to make sure these support structures here on the side of the PCB go into the side shell here, and we also need to make sure the scroll wheel goes into its standoff properly. So it's a little bit of a process to get it installed, but I will walk you guys through the full process. But before we do that, we do need to re-anchor the side buttons, which we can do by putting this ribbon connector into the open position by pulling up the black side there, and then we can take the very delicate ribbon cable here, and you want to very gently orient it into the bottom of this connector, just like that. You want to seat it in roughly like that, and once it's in place, you can anchor the sides of the connector down to hold the ribbon cable in place. Now because these ribbon cables are so finicky, what I would recommend doing now is turning the mouse on and verifying your side buttons still function. If they don't work, it's likely because this cable isn't seated properly or it's been kinked or damaged. So just be very careful with this cable, and again, make sure to test the side buttons before you put the mouse back together to make sure they are still functional. Now with that reconnected, we can go ahead and put the PCB in, which we have to do in kind of a fashion like this, where you have to orient it into the shell like this, as you can see here, it's going in at an angle. And then once we kind of get it roughly in place, you want to kind of put it like this, but see the scroll wheel here up at the top is often an issue as it's not aligning into its proper connector. So you need to pull the scroll wheel forward to allow the PCB to sit into place, and then once that's done, it should just naturally rest into place once you pull the sides of the shell out, and you can verify it's sitting properly. As you can see, these little bits of plastic are roughly even with the PCB surface. That's what you want to see pretty much across the board. Now the standoffs towards the back here won't be even, and that's normal, don't worry about that, but as long as these little plastic pieces that are like here, here, and here are sitting roughly even with the PCB surface, you should be good to go. And just to verify everything worked, go ahead and make sure your scroll wheel still functions, just because it's a little tricky to get installed, and just make sure these little protruding parts here are roughly aligned with their standoffs, just like that. And once the PCB is aligned in the shell and everything is lined up, you can go ahead and re-anchor the anchoring screws, which go here, 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 and here, and here. Now before we put in the two screws here and here, a quick note I wanted to make. Due to the fragility of the main board here, it's very easy to actually bend or crack the PCB towards this top anchoring point here, which can be very detrimental if done so because it will unstabilize the click. So be very, very careful when anchoring these screws and only screw them in until you feel a little bit of tension. Do not over tension them under any circumstances. And then once those clicks are installed, just make sure they're not over tension to make sure the PCB isn't strained. And if it's not, you are good to go ahead to the next step, which is going to be completing the top shell reassembly by reinstalling the main clicks. Now the easiest way to do this is to put the clicks in through the top of the shell like this, and then once they're into that point, you want to flatten them out as much as you can, and you want to anchor this stabilizer over that little pad right there. So you want to click it in as best as you can there. And then what you want to do is you have to figure out a way to kind of shimmy the click into the top shell so it rests over its stabilizers, which as you can see, it's a little off here. So you might need to play around with the click and just kind of wobble it into place. You might need to unhook it from its stabilizer just to adjust its position. But after a little bit of fidgeting, you should be able to get it roughly in place. And then you can take a screwdriver and just gently press the click into place, just like that. Again, be very careful of the battery, and you can double check that it's sitting flush with the shell as there's not too much of a disconnect in the heights between the button and the top shell there. And then once the click is re-anchored, we can go ahead and re-anchor the anchoring screws for it. However, as I say always, you need to be extremely careful with these screws, as if you over or under tension them, you will damage or you can break or significantly affect the feel of the main buttons. So just like we did on these two forward screws here, screw these in as you feel a little bit of feedback, and do not over tension these screws under any circumstances. it's better to under tension them and then tension them as needed than to over tension them in this situation. Also, another tip here, because we have to put the screw in through the top shell and through the components here, I'd highly recommend having a magnetized bit here so the screw sticks to it. If you don't have a magnetized bit, this is going to be extremely difficult. So take a moment to magnetize your screwdriver just to make sure the screw sticks, as it makes this process much easier. And then once the screw is stuck to our screwdriver, we're going to go ahead and we're going to go in through the top here as best we can. We're going to find the central stabilizer here, and we're going to anchor it into place. We'll repeat the process for the next click. And then once that screw is installed, go ahead and check your clicks. Make sure the main click here and the rest of the shell have the same height as we talked about earlier, and make sure your buttons have a nice tactile feel to them, which, mind you, in this case is I tension them properly. Again, if you over tension them, the clicks will be very stiff, and if you under tension them, they feel a little spongy. So again, you want to tension them so it has a nice, natural, snappy rebound. Now we're going to go ahead and do the exact same process with the next click, which is a little easier as we don't have the side button to work around here. So we'll go ahead, put the click in through the top just like this, align it into place as best we can, connect the stabilizer towards the front, click it in, and then press the click onto its standoffs the best you can like that. Then we'll magnetize our screwdriver bit and re-anchor the screws. Alright, and then once installed, we're going to go ahead again, check the click, make sure it has the same height as the top shell there, so it should just be even in height. And we're going to go ahead and check the click feel. And very importantly, make sure to check the click feel compared to the other switch, which both of them feel roughly the same. If there's a disconnect between the feel of your switches, it's most likely because the screw is under or over tensioned. So just play around with the tensioning until both the clicks feel even and have their expected click feel. Alrighty, and then with both the main clicks installed, go ahead and flip the mouse on and just verify everything still functions. So verify the side buttons are working and verify the main clicks and scroll wheel are still functioning. As long as all of these components are physically working, they should be completely fine, as we didn't remove any critical component on the main board like we normally do when we do a teardown. So it should be working out of the box, but in the odd chance something isn't working, just go ahead and take the mouse apart and reassemble it again. Again, any potential issues you're going to run into are going to be physical here due to the anchoring screws for the main clicks. That's going to be the biggest issue, or maybe some misalignment with the scroll wheel. But as long as you followed my instructions, the mouse should go together perfectly. And then once everything is tested, you can go ahead and reinstall your preferred set of skates here on the HT-S2 Pro. And with that, our teardown of the HT-S2 Pro is completed. Alright, well, in closing, overall, despite this being one of gwolves' more unique releases, as it has this ledge-like rear shaping with this traditional symmetrical front shaping, this mill still maintains the great serviceability we've seen on all of gwolves' mice, which is great to see. Again, it is a little harder to take apart compared to their other releases due to the unique design here. Again, very similar to the disassembly process we had for the HTR Pro, but the mouse is user serviceable, which is great to see, and all the mouse's internal components are repairable or serviceable, specifically the battery, as it comes with extra adhesive pads. And if you want to mod a component on the inside here, you want to paint the side buttons or add a coating to the side buttons or the main clicks, or do pretty much whatever you want to this shell, the world is your oyster, so to speak, as long as you're comfortable taking the mouse apart with its unique disassembly process. But with that, that's everything for today's episode of Teardown. Thank you very much for watching. If you enjoyed this episode of Teardown and want to see more like it, and also want to see some more in-depth reviews of products like this, be sure to leave a like on this video and get subscribed to the channel. And if you did miss my full review of the gwolves HT-S2 Pro, be sure to go check that out, as I talk much more in depth about the mouse's internal design, its specs, and performance, and much more. And of course, a massive thank you to all of our channel members who make what I do here on the channel possible. If you would like to support my efforts here on the channel with the Teardown project, the in-depth reviews, and of course the guides, consider becoming a channel member, as that is the best way to directly support my efforts here on the channel, and it gives you early access to all upcoming content such as videos like this one. So if you want to support my work and see new episodes before anyone else, become a channel member today. But that's everything for today's episode of Teardown. Thank you again for watching, and I'll catch you all in the next episode. Peace.